All right, next, slope. Well, slope is the number of units the line rises or falls for each unit of change from left to right. So if we have 2 points, we can use the formula m, which stands for slope, equals y2 minus y1 over x2 minus x1. What is that x1, y1, and x2, y2? That's representing the first point and the coordinates of the second point. So the way that we label that is just putting a subscript 1, meaning that's the coordinate from the first point, or a subscript 2 to represent that it's coming from that second point or second ordered pair. But what about if we have a graph? So that's from 2 points. If we're given a graph, then we simply refer to slope as rise over run. It's the change up or down, how far we've moved up or down, rising or falling, and then running, how far left or right we have moved. So some more vocab. A constant rate of change is 2 quantities that change at the same time. So, thinking about this in real life, you're walking at a constant rate of change when you walk without speeding up or slowing down. Your speed is remaining the same. It's constant. So classifying lines. We have different types of lines, and we're going to classify them based off of the slope that they have, what that they represent. So a positive slope, where m, or our slope, is greater than 0, rises from left to right. Opposite of that would be a negative slope. A negative slope has a slope that's less than 0, and it falls from left to right. So what does this visually look like? Well, a positive slope would look like this, going up from left to right, moving in an upward direction, and a negative slope is moving down from left to right. Then we have special cases. If we have a horizontal line, remember horizontal, I think of the horizon. The sun sets over the horizon. The horizon is a flat line. Oh, can't really see that. There we go. So that would be a horizontal line. So it's not rising, it's flat, and it can be represented by the slope of 0 over some number. Because remember, slope is rise over run. If it's not going up or down, it's not rising. So that's why this top number is 0. But we are moving left and right, so that's why the bottom number is just some number. But when we divide 0 by any number, we get 0. So a horizontal line has a slope of 0. Then a vertical line, this isn't running. So a vertical line, you can think of an elevator. An elevator doesn't go left or right, it only goes straight up, straight down. So when we think about the slope of that elevator or vertical line, we're rising some number up or down. We're moving up or down. So that top number in our slope is going to be some number other than 0. And then our run is 0 because we're not moving left or right. Now, when we divide any number by 0, we get undefined. So a horizontal line has a slope of 0, but a vertical line is the weird one. That has a slope that is undefined, an undefined slope. All right, so from 2 points, we want to classify the type of slope of the line going through -3, 0 and -1, 6. So the first thing we want to do is we want to identify these points. Let's label them. So -3, 0, we'll call this our first point. So I'm going to label that as x1, y1, my first x coordinate, my first y coordinate, and then -1, 6 is going to be my second x coordinate and second y coordinate. So I'm going to call that x2 and y2. So we want to plug those values now into our slope formula. When we do that, 6 minus 0. We're subtracting our y values. Over -1 minus -3. This is where we need to be careful. We have a double negative because we're subtracting this x1 term. But because the x1 term is negative, when we subtract a negative, what happens? It becomes a positive. So we get 6 minus 0 is 6 on the top. -1 plus 3 is 2 in the denominator. 6 divided by 2 is 3. So what type of slope do we have? A positive slope, because the solution, our slope is 3, is a positive number. Then for the second example, same thing. The first thing we want to do is label our coordinates. We got our x1, y1 coordinate, my first x and y coordinate. And then I have my x and y coordinates from my second point. We're going to call those x2, y2. So again, we're just going to plug those into that formula. And again, if you need reference, upper left-hand corner, that's the formula we're using. y2, -3, minus 1. Whoop, I found a mistake. This should be a -3. There we go, -3 minus 1, which should give us -4. -4. And on the bottom, -2 minus -2. Well, again, we have a double negative. We're subtracting a negative. -2 plus 2 is 0. This should be a -4 on the top, but it really doesn't matter. Why doesn't it matter? Well, when we divide any number by 0, we get undefined. So our slope is undefined. So this is a vertical line because it has no slope. It's an undefined slope. So your turn. You want to find the slope from each of those two pairs of points and then classify it. Is it positive, negative? Is it a horizontal line? Is it a vertical line? Once you're done, so pause the video to complete these. Once you're done, push play, and we'll go over the answers. All right, so at this point, you should be done with your turn number 2. Here are the answers. Our slope for the first one is 1, and it is a positive slope because it's greater than 0. Our second slope is 0, so that's a horizontal line because it has no slope. It's a flat line. All right, so self-quiz number 2, the first part of self-quiz number 2, that's all you're doing. Finding the slope from 2 points and identifying it, classifying it by the type of slope that it is.